In this presentation, we are going to solve our problem number 3 based on transfer function. So let's get started. Find the transfer function of the following RL circuit. The RL circuit is given to us. The input to this circuit is VIT. The output is taken across the resistor, which is Vout. The inductance of inductor is equal to L and the resistance of resistor is equal to R. And we need to find out the transfer function, and we know that the transfer function is equal to the ratio of Laplace transform of output to the Laplace transform of input. So moving on to the solution, we know that the Laplace transform of VIT is VIS, the Laplace transform of Vout is Vouts, the Laplace transform of resistor R is R, but we do not know the Laplace transform for an inductor. So let's find out the Laplace transform of an inductor, and then after that we will come back to the solution. So we are having an inductor here, and by finding the Laplace transform of an inductor, we actually find out the impedance offered by this inductor in the Laplace domain. So if we assume that IT is the current traveling through this inductor, and due to which a voltage VT is developed across it. So if we write Ohm's law expression for this inductor, we can write Vt is equal to L multiplied dit over dt. This is the expression for Ohm's law for this inductor, where Vt is the voltage developed across this inductor, L is the inductance of this inductor, and It is the current traveling through this inductor. Now if we apply Laplace transform to this equation, then we will have Vs is the Laplace transform of Vt is equal. We will not apply Laplace transform to this L because it is the inductance of an inductor. So we will take it out and we will find out the Laplace transform of dit over dt. So it will be L multiplied. The Laplace transform of this function will be equal to SIS by time derivative property. Now if we take the ratio Vs over Is, then we will get the impedance of this inductor Vs over Is, and it is equal to SL. And that's why the impedance of inductor in the Laplace domain is equal to SL, and this is the Laplace transform for an inductor. So now we know that the Laplace transform for an inductor is given as SL. And let us now convert this circuit to its Laplace equivalent circuit. The input is VIS, the impedance of inductor is equal to SL, the impedance of resistor is equal to R, and the output voltage which is measured across this resistor is equal to Vouts. Now in this circuit, this inductor and this resistor are connected in series. Because if any current flows through this inductor, the same current will flow through this resistor, and no current will flow through this open circuited branch. And if elements are connected in series, the voltage gets divided. So we can find out the output voltage which is measured across this resistor by the voltage division rule. Vouts, which is the output voltage, is equal to Vis, which is the total input voltage, multiplied with the impedance of resistor, which is equal to R, divided by the total impedance of the circuit, which is R plus SL. If we transpose Vis to the left hand side, then we can get the ratio Vouts over Vis, which is the transfer function of the circuit, is equal to R over R plus SL. In this way, we can get the transfer function of the circuit is equal to R over R plus SL. So this is the transfer function for this RL circuit. So now we are done with this lecture. We will discuss some more problems based on transfer function in the upcoming lectures. Thank you for watching this lecture. I'll end this lecture here. See you in the next one.